Okay, so today we are talking about interest formulas. So the first one we have is compound interest. The formula is A equals P times 1 plus R over N to the NT, where A is the amount at the end, P is the principal, R is the interest rate as a decimal, N is the number of times compounded in a year, and T is time in years. Then I have this table for different compounding terms. It just lists how often it happens in a year. So annually is once a year. Semi-annually is twice a year. Quarterly is 4 times a year because there's 4 quarters in a dollar. Bi-monthly is every other month, so there's 6 of those. Monthly is 12 months in a year. Semi-monthly is twice a month, so that's 24. Bi-weekly is every other week, 26, and then weekly is 52. Okay, so number 1 tells me a total of $9,000. That's my principal, how much I'm starting off with. Is invested at an annual interest rate of 2.5%. So I'm going to divide that by 100 to turn it into a decimal, which gives me 0.025. Compounded annually. How many times is that a year? And then it wants me to find the balance in the account after 5 years. So that is my time. So then I want to go ahead and plug in. Okay, does anyone have an answer here? What? No. Do you want me to type this in the calculator to show you guys? So like that. Okay, so for the next thing we're going to talk about is when something is compounded continuously, we use the formula A equals P times e to the RT, where A is again the amount at the end, E is the natural base that we talked about on Friday, R is the interest rate as a decimal, and T is time. This is typically used with modeling things like population, but it can be used with modeling money. So number 3 tells me a total of $12,000 is invested at an annual interest rate of 3%. So $12,000 is my principal. My interest rate I divide by 100 to get 0.03. My time is 4, and then I have 2 different parts for this question. The first one is to find it compounded quarterly. There are 4 quarters in a year. And then this is still using the same formula that we used for number 1. So I'm going to plug in. So the 4 that I'm dividing by is coming from my compounding frequency, the 4, for quarterly. The first 4 in my exponent is again for compounding quarterly, and the second 4 is for my time in years. Okay, so what do we get when we type this one in? But 13,523 and how many cents? 91. Because we. Oh, you didn't type enough zeros for your 12,000. For money, yeah. Okay, so then the next one is continuously. So this is the keyword to use the E formula. So I'm going to have 12,000 again, but this time I'm going to have E. R is my interest rate as a decimal, times my time, which is 4 years. Remember, the E button is, you have to go second, and the LN button is right next to 4.
No, I'm saying the difference. No, the difference.
Okay, does anyone have an answer here?
13,549.
Okay, questions here. Okay, so on number 5, this one tells me the approximate number of fruit flies in an experimental population after T hours is given by Q of T equals 20 times e to the 0.03 t, where t is greater than or equal to 0 because we can't go back in time. A wants me to find the initial number of fruit flies in the population. Any ideas on that? What? 20. It's just my p-value here. B wants me to figure out how large the population is after 72 hours. So I'm going to plug in 72. Okay, so does anyone have an answer here? So the calculator tells me 173.42. Can I have 0.42 of a fruit fly? No. So whenever I'm working with real objects that I can't have parts of, I always round up to the nearest whole number because I'm just estimating here. So instead of 173, I'm going to have 174 fruit flies. You round up when you're estimating. Always. If it's something like money where I want to find the exact value, then I round correctly.